Hello students, in the previous class we have studied about Heisenberg's uncertainty principle. Okay, continuing after that comes what? Quantum mechanical model of atom. Okay, so what is this quantum mechanical model of atom? First we will be studying about the quantum mechanics, what it is. It is the study of the motion of microscopic objects that have dual nature. Okay, actually here dual nature is significant for what? The microscopic object. Dual nature means what? The particle nature and the wave nature. Okay, so here we are going to study about the motion of these microscopic objects, like what? Electron, which has got both particle and wave nature. Okay, if we talk about the macroscopic objects, okay, what happens? In that we have studied earlier also, the value becomes insignificant, so it is negligible. So isn't it? So we are emphasizing, or we are studying about what which is significant in nature, and that is of what? Microscopic objects, okay, which have got both wave and particle nature. Okay, all the scientists said about the wave nature and particle nature, but they didn't say in a combined or in a balanced form about the dual nature of the microscopic objects. Okay, so actually this dual nature was given independently by what? Heisenberg and then Erwin Schrödinger. Okay, Heisenberg we have studied in the previous class. In this class we are going to study about Erwin Schrödinger's work for the what? Quantum mechanical model of atom. Okay, so now he gave an equation. Okay, you can see over here written H psi is equal to E psi. Okay, this is a mathematical operator. Okay, and here H stands for Hamiltonian. No need to go in deep for this word because you are going to study in the higher classes. Okay, now this psi is equal to this psi. What is this psi? See, psi is the wave function. Okay, is equal to E psi. Okay, so he explained for a system in which the energy does not change with time. Okay, so here this E psi. What is this E psi? This is the solution of the total energy of that system. Okay, so what is this total energy of this system? It is the kinetic energy of the subatomic particle. The total kinetic energy of the subatomic particle, like what? Electron we can say. We can take for example, okay? And it is the attractive potential between the electron and the nuclei. Electron is negatively charged. Nuclei is positively charged, as it consists of what? Protons, which are positively charged in nature, and neutrons, which are neutral in nature. So it becomes positively charged. So there is an attractive potential between what? Electron and the nuclei. Okay, and then repulsive potential with electron, all the electrons are having negative charge. Naturally they will repel. Nuclei, inside the nuclei what repulsive potential is there? All these are what? Solutions of the total energy of the system, which can be said by the expression or by equation H psi is equal to E psi. So now hydrogen atom and Schrödinger equation. Okay, how was Schrödinger able to give his what? The quantum mechanical model of atom. He took what? He took the hydrogen atom. Okay, and he found in that, what did he find? He found that possible energy levels of electrons can occupy corresponding psi wave function, okay, of electron associated with each energy level. He found that there are possible energy levels, okay, where electrons are found, isn't it? And this corresponds to what? The wave function, okay, and it is associated with what? The energy levels. Okay, so now here with this, okay, and with the quantized theory of what? The Bohr we have studied, okay, here he took both in consideration and he characterized a set of 3 quantum numbers, and that was what? Principal quantum number, which is represented by small n, azimuthal quantum number, which is represented by small n, magnetic quantum number, that is m L. Okay, so these all three sets of quantum number, okay, they are the natural consequence of Schrodinger equation. And from this equation, how did he take it out, with what equation? And that was given by what? This psi, h psi is equal to E psi. He got number of results in that, and from that he formulated this what? Three sets of quantum number. Yes, now these electron, okay, this electron which is present in what? Different energy states, they have got what? The wave function. And what is this wave function? It corresponds to the energy states, and it contains all the information about it. Okay, all the informations are contained in this wave function about that energy state. Okay, so here you can see this wave function is a mathematical function. Okay, so this mathematical function has got certain value, and that depends upon what? The coordinates of the electrons, and it does not have any physical meaning. So what does we mean by it does not have any physical meaning? Actually, if you see force, you have studied in physics, okay, it has got a physical meaning because it can be formulated, okay, it has got different types, okay, so force has got physical meaning, but this mathematical function, wave function, doesn't have. It only depends upon the coordinates of the electrons. Okay, so now here this mathematical function, wave function, it is what? It is saying about what? The sub-energy states. And so here it represents what? Now the atomic orbital. Okay, so here we are studying one more thing. What is that? That is psi square. This wave function is represented by what? Psi. What it is represented? Psi. So what is psi square? Psi square is the maximum probability of finding the electrons. It is the area where there is maximum probability of what? Finding the electrons. Okay, so here we have seen Schrodinger's equation with respect to what? The hydrogen atom. But it is not that. Schrodinger even took the multi-electron atoms also. Okay, and he had explained that also, but it has got very complex formulas and equations which are not required at this stage. So this is all for today. Take care. Have a good day.